Hey guys, I'm sorry I suck at making videos, but I'm back in first person mode for Math Facts episodes. So we're going to talk about 89. So what's special about 89 exactly? That's what I'm here to talk about. It has many special properties, including like the fact that 6, 7, and 89 are related. How are they connected exactly? Well, that's what I'm here to talk about. Well, this is part 1. So let's do 67 squared. What is 67 squared exactly? This is 4,489. Look, we got 8, 9 at the end of here. But what if we try 167 squared? Well, I gotta pull this thing up because I can't do that in my head. I haven't memorized it yet. 27,889. Wow. Look at that! We got 8, 9 again. But what about 267 squared? 71,289. Look at that. There's an 8, 9. I think it's because 7, 8, 9. Well, I personally agree with this because these two are both prime numbers. And another cool thing about 89 is that it's the 11th number in the Fibonacci sequence. So the first couple numbers are 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, and what comes after that? Well, 89 comes after that. Ta-da! It's the 11th number. And if you divide 1 by 89, you get the entire Fibonacci sequence. You get 0, actually. 0.01123595056179 ... It doesn't look like it, though. It's because these numbers overlap with each other, and they're just adding up on each other, like this 13, and just like turns this 8 into a 9, and this becomes 5. That's what you get. Simple like that. Which I think is pretty cool, despite 89 also being a Fibonacci number. And also being a prime number appearing in the Fibonacci sequence, and those are quite rare as well. Like, here are the rest of the Fibonacci primes. So, we have 2, we got 3, we got 5, we got 13, we got 89. There we go. And then we got, let's see, what else do we got? We got 233, 1,597, and that's as much as I know of these so-called Fibonacci primes. And do you know what else is cool about this number? Well, so let's multiply 89 by the first couple of numbers. So 89 times 2 is 178. 89 times 3 is 267. 6, 7. We just talked about the relation between those two numbers earlier. And 89 times 4, I can't do that in my head. Just give me 1 second. Alright guys, so it's been a couple minutes and I just wrote down the first couple multiples. And these look pretty random on their own until you realize that this digit takes down from 8. This one also goes down from 7. However, this one goes up from 8. Look at that. So we have 8, 7, 6, 5, 4, 3, 2, 1. 7, 6, 5, 4, 3, 2, 1, 0. And then 1, 2, 3, 4, 5, 6, 7, 8. Which is pretty cool. And here's some other facts about it. So I don't have any room to fit anything else about it on this piece of paper, but luckily I carry an extra one. So let's do 9 times 5. Simple enough. That's 45. Everybody knows this. But if you were to do, just multiply this by 10, and then subtract 1, 10 times 9, minus 1. It gives you, let's just cross it out because that doesn't equal 45. So this equals 89. Now multiply this by 5. Now what does 89 times 5 equal? Well, it equals 445. I think we just found the infinite 45s glitch. This is it. And what if we were to multiply 9 by 45? Well, that's 405. And do this same thing again. 89 times 45, that's 4005. We found another version of the infinite 45s glitch. Look at that. But 889 times 45, that is 40,005. And let's go further. 8,889 times 45. Well, I'm sure you guys are like, isn't it 400,005? Well, you guys are correct. Look at this. Take a look at that. Isn't that cool? We found the infinite 45s glitch.